Section 2.5 Applications of Quadratic Equations. So in this section we're going to do something similar that we did in section 2.2 where we did applications of linear equations. What did we do there? We basically took a word problem, we wrote down the knowns and the unknowns, created an equation out of it, and that equation was linear, and then we solved that linear equation. In this section we're going to do the exact same thing. We're going to start with a word problem, we're going to write down the knowns and the unknowns, create an equation out of it, but this time the equation, instead of being linear, it's going to be quadratic, and then we'll solve it. We just learned in the last section, in section 2.4, how to solve quadratic equations. We had a couple different methods for a few different methods for solving them. We could solve them by factoring, using the square root theorem, we could use completing the squares, or we could use the quadratic formula. Okay, so let's go ahead and take a look at some of these problems. The guidelines for setting up these problems is exactly the same as the guidelines in section 2.2. So if you've forgotten those, make sure you guys go back and take a look at your notes or look at the video on how to set up word problems in section 2.2. So in this section, in this first problem, we are going to fence in a rectangular field, and we know that for some reason we want the field to have an enclosed area of 75 square feet. We also know that we want the width of the field to be 3 times longer than the length of the field. What are the dimensions of the field? So it's something like this. If I have a rectangular field, I'll call this my length and this my width, and it's going to enclose an area, and they've told us that the square footage of the area is 75 square feet. So they asked us what are the dimensions, what are the length and the width of the field. So let's write down what's given to us. They've told us that the area of the field is 75 square feet. Okay. They've also told us that they want the width to be 3 feet longer than the length. So they want the width to be the length plus 3. So it needs to be 3 feet longer than the length. So if the length is 5, the width has to be 8. If the length is 20, the width has to be 23, 3 feet longer. So this is what's given to us. Okay, and they want us to find the length and the width. That's what they want us to find. Now, once we write down our knowns and our unknowns, we have to find a formula that relates these three things. Since we're talking about a rectangle, and the length and the width and the area, we should start with the formula for the area of a rectangle. From geometry, we know that the area of the rectangle is length times width. Now, if you recall from the guidelines on how to solve word problems, we always want to make sure that the formula that the equation that we end up with has only one unknown. Right now, you can think of this, even though it's a formula, you can think of it as an equation because it has an equality in it, but it has three unknowns: area, length, and width. So let's write down, plug in everything that we know, and hopefully end up with an equation that only has one unknown. What was the area? The area was 75. The length wasn't given to us, so let's leave it alone, but we do know what the width was. Width was the length plus 3. Make sure you put parentheses because there are two terms here. Now we can see that this equation only has one unknown. So that's something we can solve. Anytime you solve an equation, we want to get rid of the parentheses. So let's do that. So we get L squared plus 3L. And like I told you at the beginning of this section, once we set up our equation, it should be a quadratic, degree 2, which it is in this case. You can see that. Anytime you have a quadratic equation, you always want to move all the terms to one side. You always want 0 on one of the sides. So we get L squared plus 3L minus 75 is equal to 0. Now that we have that set up, let's go ahead and solve this. I can solve this equation. You can try to factor it, okay, and you'll notice really quickly that it cannot be factored, so we can't use that. And if you want to check to see if something can be factored, we can find the discriminant, which is what, b squared minus 4ac, and we can show that that is not a perfect square. I'm not going to waste time to do that, but you guys can definitely take a few minutes and figure that out. So it cannot be factored. If it cannot be factored, then you're down to two choices. I cannot use a square root theorem because of this middle term. You can only use a square root theorem when you have a square and a number. But when you have the middle term, then you cannot do that. So that's out of the way. So we have only two choices left: completing the squares or the quadratic formula. Completing the squares will work here, and so will the quadratic. They both always work. It's just a matter of which one do you want to use. I prefer the quadratic formula if I have a choice. So let's go ahead and use the quadratic formula. Out here A is 1, B is 3, and C is negative 75. So if you remember, the quadratic formula tells you what? Whatever you're solving for, in this case we are solving for L, so L is minus B plus or minus square root of B squared minus 4AC divided by 2A. Anytime you use a quadratic formula, always write it down first. It helps you to memorize it. I'll finish it here. So the length is, B is what? 3, negative 3 because of the minus B, plus or minus the square root of B squared minus 4AC. And I've told you before, you should always do the discriminant on the side. It's just easier. So let's just do that here on the side. You have D is B squared minus 4AC. B is 3 squared minus 4 times 1 times C. C is negative here, so we do need parentheses. So we get 9 minus, well, plus, okay, we get 300. So we end up with 309, which you know is not a perfect square. That's why we could not factor this. So in this case, I can just plug it in here, 309 divided by 2 times A, so that's just 2 because A is 1. And now it's just a matter of plugging it into your calculator to figuring out what those values are. So my length is going to be, okay, if I use the plus sign here, okay, let's do that on the calculator so you guys can see that. Okay. So if I use the plus and I have minus 3, oops, I need parentheses on the outside since I'm going to divide by 2. Minus 3 plus the square root of 309, divide that by 2. So we get 7.289. So let's do that. So we get 7.289. So we can round that off there. So that's one answer. Or remember that we also have to do the minus sign now. So if I do the minus sign, I'll just hit second and enter, and then go back and just change that sign to a negative. I get minus 10.289. So we get negative 10.289. Now my length can be either this or it can be this. So let's take a minute and think about it. Length is a measure of distance, so it cannot be negative, so we know that this is not possible. So the length must be 7.29 if you round it off. So my length is 7.29. Okay, so what is my width then? Remember, we got to find both the length and the width. Well, let's go back up here and look at it. What was the width defined as? The width was length plus 3, so this implies the width is length plus 3. So we get 7.29 plus 3, so we get 10.29. So that's what the width would be 10.29. So you do need to write your answer as a sentence. I'm not going to do that here. Again, for the sake of time and room, you can say the length, I'll just do this one. Length is 7.29 feet, and the width is 10.29 feet. Okay, of the rectangular field. So you do need to write that down. But the key thing out here was the setup was exactly the same as what we did with linear problems. The only difference was when we set up our equation, we ended up with a quadratic equation. So we had to move everything to one side because we always want 0 on one side when we solve quadratic equation. And then we went ahead and used the quadratic formula to solve it. Okay, let's go on to the next problem. We have two cars start out at the same point. One car starts out driving north at 25 miles per hour. So let's just draw a picture to see what it looks like. So here's car A going in this direction. So this is car A, and it's traveling at 25 miles per hour. Okay, and 2 hours later, a second car starts driving east in this direction. So this is car B, and it's going at 20 miles per hour. After how long after the first car starts traveling does it take for the two cars to be 300 miles apart? So after some time, the distance between the two of them is going to be 300 miles. That's what they've told you. Okay, so here's a setup and a picture. The picture is very useful in this case. So let's take a look at it. It's a motion problem, so we know we always set up a motion problem in grid. So let's create a grid. Rate times the time is equal to the distance. That's a formula we used in section 2.2, so we're going to use the same one. Car A, car B. Do we know how fast car A was traveling? Yes, we know it's traveling at 25 miles per hour. This is the rate of the speed column for the two cars. This is car A, so this is 25. And car B was traveling at 20 miles per hour, so we know that. Now let's take a look at the time. We don't know the time of either car, but we do know one thing. Car B started 2 hours later. So just let's take a minute and think about it. If car A was already in motion, was already driving for 10 hours, then car B was only driving for 8 hours. If car A was driving for 15 hours, car B was only driving for 13 hours, because it started 2 hours later, so it was driving for 2 less hours. It was in motion for 2 less hours. Okay, so we don't know how long car A was in motion, so let's call it X. So car B would be X minus 2 because it started 2 hours later. I hope that makes sense to you, and because that is the key to this problem. If you understand that, because we know it started 2 hours later. Okay, how do I find the distance? That's easy, because to find the distance we take the rate of each car and the time each car was traveling and multiply them. So we get 25x, and you get 20 times x minus 2. So now we know the distance car A traveled. We know the distance car B traveled. Now it's just a matter of creating an equation that we can solve. So let's see how do we go about doing that. Okay, so how should we do this? Well, this is the distance car A traveled. We know that. I'll call it capital DA. This is the distance car B traveled. Okay, so we want these two distance, after some time, whatever these two distances are, these two cars have to be 300 miles apart at that time. Okay, so you can see this is a nice right triangle, so we can use something called the Pythagorean theorem from geometry, which told us what? If you have a triangle like this, if this is A, B, and C, it's a right triangle. That told me what? The square of the hypotenuse, this is the hypotenuse, the angle, the side opposite 90 degrees. The square of that is equal to the sum of the square of the other two sides. So that's what we're going to utilize here. So in our case, the hypotenuse is 300. So we say 300 squared is equal to the sum of the squares of the other two sides. The square of this side, which is the distance traveled by car A, plus the distance traveled by car B. That will be that. So we're using two different ideas in this problem. We're using the idea of motion, and then we're also using the idea of the Pythagorean theorem to help us set up our equation. So let's do that. So we get 9 is equal to, I'm squaring that. What is distance traveled by car A? That's right here. This is my distance column, this is my car A row. So that's 25 x squared plus distance traveled by car B would be 20 times x minus 2 squared. Remember, that's a distance traveled by car B. So now we just want to square everything, get rid of the parentheses and solve. So we get 90,000 is equal to 625x squared. I'm just squaring this, plus I'm going to square the 200, which is 400 times x minus 2 squared. I'm just distributing here. Okay, so that's what we did. Okay, and if you want, we could also have done this over here. We could have multiplied this out. So if we had done that, we would get 20x minus 40. So we could have just done that. Let's do that. Let me make it easier to work with. So that's 20x minus 40 squared. Okay, so now we have to expand this. Remember the formula that we did couple sections in the last chapter, a plus b squared You square the first number, plus you take 2 times the first and the second number, plus you square the second number. Oops, sorry, this is wrong. I apologize. It's a plus b the whole square. The binomial square is what we are doing. Okay? Sorry about that. So in our case, we have a minus in the middle. So if we had a minus here in the middle, then the only thing that changed is this became a minus and then this became a minus. Okay? Everything else stays the same. So let's utilize that. So you square this guy because it's a binomial. You can see it's a binomial. You have two things squared, binomial squared. So you get 400x squared when you square this. Then you take this times this, so you get 20 times 40 is 800x, and you multiply that by -2, so you get minus 1600x. Okay. Plus you square this. Square root of 40 is 1600. So that's what we end up with. And clearly these numbers are really huge. I need to move this to the other side since it's a quadratic. So I get 625x squared. Okay, oops, I need to add some of these squares, don't I? There's this one and this one I can add. So I get 1025x squared minus 1600x, okay, minus 88,400 is equal to 0. I moved the 9,000 to the other side, and then it became a -9. And this one, you can clearly see the numbers are huge. I would strongly encourage you to put this into the quadratic formula and do it. This is A, this is B, this is C. And just for the sake of time and stuff, I'm just going to give you the answers, but you can definitely plug it into the quadratic formula. I'll do it up here since I have no room down there. So if I plug it into the quadratic formula, I'm solving for x, so I get x is equal to, okay, we get 32 plus or minus 20 square root of 365 divided by 41. That's what we end up with. Okay. And if you use the plus sign here, if I use the plus sign in between these two numbers, okay, I end up with 10.099. And if you use the minus sign between the two numbers, we get negative 8.539. Okay. So what is x in this table? X represents time, and again time cannot be negative, so that tells me that this is not true. So the time must be x, must be 10 point. So this is roughly 10.10 if you round it off. Okay. So that tells me that it would take car A, because we're looking for the time of car A, I think so, wasn't it? How long after the first car, which is car A, started traveling does it take the two cars to be 300 miles apart? So it would take 10.1 hours after the car A started traveling for them to be 300 miles apart. So I would expect you to write the answer down. So this is the answer to this problem. Okay, I know I skipped some steps, but it's just a matter of plugging this into, and these numbers are really big. You can just plug them into the calculator and you can do the calculations using the quadratic formula. Okay, so I use the quadratic formula to get from here to here, and then we ended up with this answer. So the answer to this problems, it takes car A 10.10 hours to be 300 miles from car B. Okay, so that's the answer to that problem. Okay. The next question is another word problem, and this one has to do with work. So if you remember the work problem, we again set it up in our grid. So these all problems are the same as the linear ones, and the formula was rate of work, multiply that by how long you were working, time working, is equal to task completed. Okay. You had two envelope stuffing machines, so I'll just call that machine A and B. Okay. A office has two envelope stuffing machine. Working together, they can stuff a batch of envelopes in 2 hours. If they work together, time working together is 2 hours. If they work together, they could finish the job in 2 hours. Working separately, it takes the second machine 1 hour longer than the first machine. Okay, so it takes the second machine 1 hour longer than the first machine to stuff the envelopes. How long would it take each machine to do the job? So let's create some variables. So let's go let x equal to the number of hours it takes the first machine. Takes machine A. Okay, so if it takes machine A x hours to do the job, what is the rate of work for machine A? It'll be 1 over x. Okay, that'll be the rate of work for machine A. Alright, how long will it take machine B to do the job? According to this, what does it say? Working separately, it takes the second machine 1 hour longer than the first machine to do the job. So then it would take x plus 1 hours. So it'll be number of hours it takes the machine B to do the job by itself, because it would take 1 hour longer than machine A. If it takes machine A x hours, it would do that. So similarly, if it was 5, it would be 6. So what is the rate of work for machine B? It's 1 over x plus 1. So there's your setup. Remember, rate of work is always 1 over however long it takes them to do their job alone. So to get the task completed, you multiply this, so you get 2 over x. We get 2 over x plus 1. This is the job that was completed by machine A. This is the part of the job completed by machine B. If you add them up, that should give you that one job they did together. So we know that 2 over x plus 2 over x plus 1 should equal to 1. They complete that one job together. So let's solve this. This one's a little bit different than the other equations because this one has fractions, so we need a common denominator. This and this cannot be factored any further. To find the common denominator, we always factor our denominators first. In this case, it cannot be factored, so you just take each factor to the highest power, 1, and x plus 1 to the first power. That's my common denominator, so multiply each term by that. So let's do that. 2 over x plus x times x plus 1 times 2 over x plus 1 is equal to x times x plus 1 times 1. And we are doing this why? To get rid of the fraction. So in this case, the x's cancel. So you go ahead and distribute the 2. So we get 2x plus 2 plus the x plus 1's cancelled. So we get 2x is equal to, out here there's only 1, so that doesn't matter. We can just distribute the x. So we get x squared plus x. So we did end up with a quadratic. So because we ended up with a quadratic, we should move everything to one side. So I'll move everything to the right hand side. So we get x squared plus x minus 2x minus 2 minus 2x is equal to 0. So I'm moving all of these terms to the right, so they all become negative. Collect the terms, so we get x squared minus 3x minus 2 is equal to 0. Okay, so that's what we end up with. Now again, this cannot be factored, and if you're not sure, let me go ahead and do it this time. A is 1, B is minus 3, so let's put parentheses, and C is negative 2. So to check to see if you can factor this, you take d is equal to b squared minus 4ac. So we get negative 3 squared minus 4 times 1 times c. So you get 9 plus 8, so we get 17. That's not a perfect square. 16 is a perfect square, but not 17. So we can use a quadratic formula. We are solving for x, so let's call it x is minus b plus or minus the discriminant, b squared minus 4ac divided by 2a. I'm choosing to do it this time because the numbers are small, so I don't need my calculator. So minus b, so you get negative of negative 3 plus or minus the square root of 17, because we just calculated this right there, divided by 2 times 1, so we get 3 plus or minus 17 over 2. Let's go back for a second and make sure we know what x is. X is the number of hours it takes machine A. So x is time. Can time be negative? No, so remember that, okay? Alright, so I have two answers here, one with the plus sign and one with the minus sign. If you do the one with the plus sign, you get a positive answer. You just punch this into your calculator, 3 plus square root of 7 divided by 2. So we get 3.5616. And when I use the minus sign, I get negative 0.5616. We can disregard this answer, because in the context of this problem, that answer makes no sense. But if I was solving this equation that is not associated with a word problem, then both those answers are good. It's just that because this equation belongs to the word problem, and the word problem tells us that x is time cannot be negative, so we can disregard that. So it tells me that it takes, I'll abbreviate machine A 3.56 hours to do the job alone, and machine B 4.56 hours to do the job alone, because machine B takes 1 more hour. So those are some examples of application of quadratic equations. The setup is exactly the same as section 2.2 for linear. It's just that you end up with a quadratic equation once you set up the problem. So I'm hoping that once you do the problems, homework problems, you'll get a better understanding on these problems.